discuss the mechanism and origin of monsoon winds, and explain the role of El Nino on monsoon circulation. As monsoon have become better understood, the term monsoon has been broadened to include almost all the phenomena associated with the annual weather cycle within the tropical and subtropical land regions of the Earth. The monsoons, which have helped balance global temperature and sustain life on Earth, affect a vast area of the globe, from Africa across the Asia to the Pacific, northern China and the Himalaya to northern Australia, and even Mexico and parts of Central America, directly influence the lives of over half of the world's population. In India, 50% of the arable land is irrigated solely by monsoon rain. There are two Indian monsoon seasons. The summer and or southwest monsoon comes in. Southwest monsoon comes in from in the direction of the Africa, then brings heavy rain to the west and large areas of northern India between June and August. This is when Asia reaches in. The winter or northeast monsoon sweeps down from the plateaus of Asia and the Himalaya and brings rain and cooler weather to southeast India between October and December. This is when Asia reaches out. Later for 1,000 years or more, Arab those have relied on these phenomena and the trade winds, the sail across the Arabian Sea to India ahead of the main force of the southwest monsoon, returning with fresh cargo on the winds of the northeast monsoon. It is not surprising that the word monsoon derives from the Arabic word mawzin, meaning season. The key of understanding the basic monsoon mechanism lies in the fact that land heats up and cools more quickly than the sea, the latter holding its temperature more or less steady. As the sun moves north, bringing our summer heat, the land stimulates steadily, gets hotter and hotter, while the temperature of the oceans lags far behind. The effect on a huge land mass like Asia, as the hot air rises over the land, leaving below a vast area of low pressure, is to draw a massive amounts of air from over the ocean. Where higher pressure are maintained, there is the southwest monsoon pattern. It is the wind and not the resulting rain, which is defined as the monsoon. Around September, with the sun fast retreating south and north, the northward landmass begins to cool rapidly. As it cools, air pressure boils over the land. Meanwhile, the oceans are still holding their warmer summer temperature. The cooler high pressure of air over inland Asia then starts to move down towards the lower pressure areas of the ocean, and our northeast monsoon is born. Asia breathes out, and we enjoy our October-December period of rains. Meanwhile, the air moving out from inland Asia to replace the balanced by warmer air moving in northwards from the ocean at around 40,000 feet. Empirical evidence is presented to support that the interdecadal variation of the Indian summer monsoon, that of the tropical SST and parts of the tropical coupled ocean atmospheric movement. The interdecadal variation of the Indian monsoon rainfall is strongly correlated with the interdecadal variation of the various indices of El Nino Southern Oscillation. It is also shown that the interannual variance of both IMR and ESNO indices vary in place, in phase, and follow a common interdecadal variation. However, the correlation between the IMR and Eastern Pacific SST, or between IMR and the Southern Oscillation Index on the interannual timescale does not follow the interdecadal oscillation. The special patterns of SST and sea level pressure associated with the interdecadal variation of IMR are identical to those associated with the interdecadal variations of ANSO indices. As has been shown earlier in the case of ANSO, the global patterns associated with the interdecadal and interannual variability of the Indian monsoon are quite similar. The physical link through which an ENSO is related to decreased monsoon rainfall on both interannual and with El Nino opposes the prevailing interdecadal interannual and interdecadal timescale has been investigated using National Centers for Environmental Prediction, National Centers for Atmospheric Research Analysis products. The decrease in the Indian monsoon rainfall associated with the warm phase of ENSO is due to an anomalous regional Hadley circulation. Descending motion over the Indian continent and ascending motion near the equator situated by the ascending phase of the anomalous Walker circulation in the equatorial Indian Ocean. It is shown that to a large extent both the regional Hadley circulation anomalies and Walker circulation anomalies over the monsoon regions associated with the strong phase to the interdecadal oscillation are similar to those associated with the strong phase of the interannual variability. However, within a particular phase of the interdecadal oscillation, there are several strong and weak phase of the interannual variation during a warm eastern Pacific phase of the interdecadal variation. The regional Hadley circulation associated with El Nino reinforces the prevailing anomalous interdecadal Hadley circulation while they are associated. Similarly, you can see rising air, descending air, low pressure, high pressure, equatorial, Peru, Australia, Pacific Ocean, surface flow, high pressure. Okay, and here mainly area, B area, El Nino. It is El Nino, mainly high altitude flow, descending, rise air, high pressure, low pressure, surface flow, Pacific Ocean, southern oscillation, Walker circulation, and El Nino. With La Nina opposes the prevailing interdecadal Hadley circulation during the warm phase of the interdecadal oscillation. El Nino events are expected to be strongly related to monsoon droughts, while La Nina events may not have a significant relation. On the other hand, during the cold eastern Pacific edge of the interdecadal resistive oscillation, La Nina events are more likely to be strongly related to monsoon floods, while El Nino events are unlikely to have a significant relation with the Indian monsoon. This picture explains the observation that the correlations between the IMR and the UNSO indices on the interannual timescale do not follow the interdecadal oscillations, as neither takes another phase of interdecadal oscillation favors as stronger or weaker or correlation between monsoon and the UNSO indices. So thank you.